All right, so you guys know this entire unit we've been talking about exponents. We first introduced the exponents with regular exponents. What's a base? What's a power? I kind of reviewed that with you yesterday. Then we started to talk about zero exponents and negative exponents. You know, what's anything to the power of zero going to be equal to? Yeah, just a one. How do you get rid of a negative exponent? What do you essentially make it into? Javen? Yeah, in order for us to get rid of any negative exponent, you're going to make it into a fraction where the numerator is going to be a 1. Boom. Yeah, of course. All right, so what are exponent power laws? The first thing I need to tell you is the following rules only work in multiplication or division questions. So if you have addition and subtraction, you cannot use these rules. The bases must always match and must never change. So the two things you're looking for before you can apply an exponent rule is, do the bases match, and is there a multiplication and a division sign or a division sign? Let's go over the rules and then I'll show you examples to help it make a little bit more sense. Rule number 1 is when you are multiplying powers with the same base, you're going to add the exponent. So take a look at the first example. It says 14 to the power of 5 times 14 to the power of 3. Those are massive numbers, you guys. That's basically like saying 14 times 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 14. You don't have calculators, so it's going to take you a very long time to figure that out. And also, I would never ask you to multiply such large numbers. So for a question like this, I would just say, rewrite this as a single exponent. You don't need to solve, just rewrite it as a single exponent. Are the bases the same in this question? The bases are the big numbers. So are they all the same? Yes, they are. Is there a multiplication or a division sign? There's a multiplication sign. So how do we simplify this question? Well, all we're going to do is we're going to add the exponents together and we're going to get our final answer. So take a look at the exponents. We have a 5 here, a 3 here. 5 plus 3 is 8. And so our final answer would just be 14 to the power of 8. You don't need to solve this any further. You just leave it as that. Now, there may be questions where I say solve. And if I tell you to solve them, I'm going to be giving you baby numbers. So like something like 2 to the power of 3 or 2 to the power of 2. Nothing as massive as this. Look at the next example. We have 2 to the power of 3 times 2 to the power of 4 times 2 to the power of 10. They have the same base. They're all 2s. There's a bunch of multiplication signs. So I'm going to be adding the exponents together. 3 plus 4 is 7. 7 plus 10 is 17. So our final answer is going to be 2 to the power of 17. That make sense? Okay. Rule number 2, what happens when we have a division sign? So if you take a look at the examples I've given you, when dividing powers with the same base, subtract the exponents. So you can write a division question in 2 different ways. You can write it with the actual division sign, or you can write it as a fraction with the number on top of another number. Let's look at the first scenario. 6 to the power of 10 divided by 6 to the power of 7. My exponent here is a 10. My exponent here is a 7. There's a division sign. So now I'm going to be subtracting the exponents. 10 take away 7 is going to give me a 3. Do my bases change? No, the bases always stay the same. A question like this, yes, it looks like a fraction. However, every fraction question is just a division question, right? It's just this number divided by this one. So because the bases are the same, you're going to take your exponents, 11 and 8, and you're going to subtract them. 11 take away 8 is going to give you a 3, and then that would be your final answer. And then rule number 3 is called a power of a power. So when you have a number that is to the power of another number, what you're going to do is you're going to be multiplying those numbers together. So 2 to the power of 5, everything to the power of 3, multiply the 5 and 3, and you're going to get 15. Another example is 4 to the power of 5 to the power of 2 is just going to be 4 to the power of 10. Just multiply the exponents, correct. Now, you guys, I hate to go over rules because sometimes it just makes more sense to do examples. We're going to go ahead and start doing examples. And the rules I gave you were pretty simple. We're going to actually be working with fractions and negative exponents and all sorts of stuff to apply these rules. All right, let's go ahead and try example number 1. And questions like these are pretty quick. So I'm going to be going around the class a lot. I want full participation. You obviously have the right to pass, but I really want you all to try questions like this. So question number 1 says state as a single power, but don't evaluate and solve. So that means you don't have a calculator. I'm not going to expect you to multiply massive numbers. I just want you to tell me what the simplified version would be. Dante, what do you think the answer to this is? 4 to the power of 9. And why did you know to add them? The bases are the same. And what sign do you have? It's a multiplication sign. Perfect. How about question B? Oscar? Excellent. Perfect. Question C. Manak? And how did you figure that out? Perfect. And Abrar, do you want to try the next one? Good job. And how did you figure that out? Yep, and the bases are all the same. They're multiplication signs. You're just going to add them up. Excellent. Let's keep going. How about a question like this? It's now division. Sirsha? Yep, so this time we're taking away. By the way, even though the question says don't solve, for a question like this, I could ask you to solve because it's super easy. It would just be 25, but I would never ask you to solve 9 to the power of 17 or 5 to the power of 19. Julia, do you want to do the next one? Sorry, I'm just going to write this over here. And then you said 2 to the power of 3. Good. The bases are the same. Let's keep going. Question C. Zara? Careful. It's a multiplication sign. So would you add the exponents or subtract? Yep. Good job. 8 to the power of 15. Perfect. How about question D? It is a power of a power. Sienna? Add them together. Yep. The next one, question E. Anishit? Perfect, because again, it's a power of a power. And then our very last one on this page, question F. Abrami? 17 to the power of 56. Yep. And of course, you can have your multiplication table out if these numbers are a little bit big for you. Okay, how did you find that? Easy peasy? Okay, that was just starting off. We're trying to figure out what our power laws are. So we kept the numbers pretty straightforward. Question number 3 is the same instructions. It says state as a single power, but don't evaluate and solve. I'm not going to do all of them. I'm going to pick and choose a couple. So let's start with question letter B. And I know that there isn't a lot of space. I hate when there's not a lot of, which I may actually have to do with you. So let's go ahead and try them and see what we get. So these questions are clearly a little bit more challenging than the ones that we did before. Dante, you want to help us out with this one? Oh, well, let's do it step by step. According to BEDMAS, we're going to do multiplication, division, whatever comes first. So I'm going to go ahead and do this multiplication. We have the same base and we have a multiplication sign. So Dante, what are we going to do with these exponents? Good. So what are we going to get here? Yep, good job. 10 to the power of 14. 6 plus 8 is 14. And then I'm going to write 10 to the power of 7. So really, these questions just end up being big BEDMAS questions. And then Dante, you want to keep going? Same base division sign. You're going to subtract the exponents. 10 to the power of 7 would be our final answer. Good job. It does work the other way. Yeah. It's just you have to be careful. Like if there is a plus sign or brackets, just make sure you're always following BEDMAS rules. According to BEDMAS, we got to do what's inside the bracket first. So I have 29 to the power of 3 times 29 to the power of 8, same base, multiplication sign. Javint, what am I going to get? Yep, because you just added the exponents. And now this is a power of a power question. So what will our final answer be? 29 to the power of 22. And thankfully, the instructions told us not to solve. We just have to express it as a single power. Okay, question letter D. Again, BEDMAS. We got to solve what's inside the bracket first. 5 to the power of 19 divided by 5 to the power of 14. Aritra, what do you think you're going to get for this? Yeah, and how did you figure that out? Good. And then we can't get to the power of 3. Aritra, keep going. What will our final answer be? Good job. 5 to the power of 15. Am I going too fast or is this okay? We're all good with it? All right. Question F looks super intimidating because it has a whole bunch of really large numbers that are trying to scare us, but we will not be scared because we know how to do this. We don't need to solve them. We don't need calculators. We're just simplifying. I always do the numerator separately and the denominator separately. So whenever I get a question with this, I make my fraction bar and then I just look at, I look at them as two different questions basically. Let's go ahead and first solve the numerator. 26 to the power of 4 times 26 to the power of 9 times 26 to the power of 12. They're all the same base, all multiplication signs. We're going to add the exponent here. 26 to the power, let's see. So 9 plus 4 is 13. Yep, you got it right. It'll be 25. And then what do you think the denominator will be? Good job. 26 to the power of 23. Do you want to continue? Yep. Yep, and then that would be our final answer. So again, a big, massive question, but we did it in 2 steps. Oh, it's not even on. Oh, I didn't. Oh, it was showing up. Sorry, I didn't realize it was lagging. Okay, I'll leave it up here for a second. All right, question letter I. I've already done this. I'm going to pause the recording while this catches up. Are going to begin with what's inside the bracket. So I'm going to keep the first part of this question the same, and then I'm going to solve what's inside of the bracket. I have the bases are as 3, a division sign. I'm going to go ahead. Should I add the exponents or subtract them? Subtract. What's 19 take away 10? Can you just say it out loud? Yeah, it's going to be 3 to the power of 9. So all I did was I took what's inside of this bracket and I subtracted the exponents. And I ended up getting 3 to the power of 9. I'm going to keep going. I have 3 to the power of 21 divided by 3 to the power of 9. Same basis, division sign. I'll subtract these numbers. Oscar? 3 to the power of 12 as my final answer. No, you got it right. Great work. We keep going. So now the most complicated question in this section looks like this. Again, BEDMAS tells me I need to clean up what's inside the bracket first. And inside the bracket, I have a massive fraction. So what I do with my fractions is I solve the numerator separately and I solve the denominator separately. Let's look at the numerator. 6 to the power of 3. And by the way, you guys, if you are someone who maybe gets anxious during tests and you look at a question and you just blank, my suggestion to you is just look at it piece by piece. Don't look at the question overall. Start by looking at one part of it. So let's just look at the numerator. Ignore all the other numbers. 6 to the power of 3 times 6 to the power of 14. Same base, multiplication sign. What are we going to get? Oscar? Yeah, and how did you get that? Three plus 14, good, perfect. And then how about the denominator? Farabi, you want to try that one? What do you think about this? 6 to the power of 10, yeah, and do you want to just keep going? So this is all to the power of 3. Now, do you want to solve what's inside the bracket? 6 to the power of 7 to the power of 3. How did you get the 7? Yeah, it's a division question. So you're just going to subtract 17, take away 10 to get 7, and then to finish the question. Yep, and you figured that out by just a power of a power. Oh, oh, good. I'm going to use it more often. Savvy to help. All right, volunteer to help me with question 4F. Jen, go ahead. Yep, so first you added these exponents to get 74, then you subtract these exponents to get 3 to the power of 2. And remember, the question does say we need to solve it. So an easy number, 3 squared, is just going to give me a 9. Perfect. Question 4G. Do you want to try it, Manas? Go ahead. Yep. Yep. Yeah, keep going. Yep. 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 Yeah, perfect. Just remember, BEDMAS, you need to solve what's inside the bracket first. And then this is sort of like an exponent. So you have to multiply 1 and 7 to get that. Do you guys get these as answers? Yeah, okay. And then the last one in this section, this is, again, something I would do separately. So I would solve this and then this separately. When I say separately, though, I don't mean like solve it on 2 separate sheets of paper. You still have to do it in the same line and keep everything together, have a good solution set. But I just think of this as being like one part of the question and this is another part of the question. So who wants to help me with this very first part of the question? Maybe Julia, go ahead. Yeah. Yep. Yeah, and then this is the second part. How'd you get 1? Yep. Good, keep going. Yep. Yep. Good. Yeah, and now this question is a little bit big. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and I'll add another one. Here's how I would do this. I know 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. And 128 times 2, would you guys get as an answer? 256. I do think that these numbers are big, but because you're multiplying by 2s, it's not something that is impossible. I'm going to try to avoid numbers that large, but it's good practice. All right, how did you guys like these set of questions? So you can tell that these questions are just getting increasingly more difficult. These ones are the hardest ones. They have fractions and they have negative exponents. So how would we solve them? Let's take a look. Okay, so for the first question, yes, there are fractions, but no, we're not going to be afraid of them because look, the fractions are all exactly the same. The bases are all the same, 1 over 3, 1 over 3, 1 over 3. It's just like any other number. So we're still going to be using our power laws just like we did before, except this time we're going to be dealing with fractions. So if you take a look at the numerator, we have 1 over 3 to the power of negative times 1 over 3 to the power of 2. What is base going to be in this question? The base hasn't changed. So what am I going to put over here inside the bracket? Another way to think about it, oh, you can't see anything. I'm sorry, I wish It's coming. Okay, now that you can kind of see it, what number is going to go inside the bracket? Or what's the base in this question? It's just going to be 1/3. Good. So we don't change the fraction. It's still a 1/3. All we're going to do is we're going to look at the exponents. And I guess you guys are just going to have to look on your sheet because it's taking so long for it to come up. You're going to look at your exponents and you're going to solve it. So this is like saying -3 plus 2. The first exponent plus the second exponent. If you would like, you can even write that down, -3 plus 2. What is -3 plus 2 equal to? -3 plus 2. What do you guys think? Integer rule. So different signs, subtract the numbers, take the sign of the bigger number. 3 take away 2 is just 1. What is the sign of the bigger number? Negative. So it's going to be -1. Was anyone able to get 1/3 to the power of -1 for this question? Yeah, okay, good, good. And then at the bottom, we still have our 1/3 to the power of -2. Now, what do we do here? Well, our bases, oh my gosh, it's taking so long for it to show up. How do I speed up the internet, or how do I speed up a connection? So our base is still going to be 1/3. But look at what we're going to do. We're basically thinking of this as -1 minus -2. And if this helps, just take a rough sheet of paper and write it down. Don't write it down in the actual solution because it's not a part of the solution, but you can definitely write it down somewhere else. You're taking the first number, -1, division means subtraction, and then you're putting the second one down. Power law, I cleaned up the sign, so it's -1 plus 2. And what's this equal to? -1 plus 2. -1 plus 2. What do you guys think? It's going to be a +1. I know it's so hard to do it when you can't even see it. But -1 minus -2 will be -1 plus 2. And -1 plus 2 is just a whole number 1. And so the answer to this is going to be simply 1/3. If you did not get this question correctly, what are some things you did that maybe got the wrong answer? Like where do you think your struggles were? Or did everyone get the question right? Okay, next question. We have 1/6 to the power of 9 times 1/6 to the power of 2 divided by 1/6 to the power of 12. So bedmath tells me I'm just going to go in order, multiplication first. I'm going to add up these exponents. So it's going to be 1/6 to the power of 9 plus 2 is 11 divided by 1/6 to the power of 12. By the way, if these bases were not the same, you could never use power laws. You have to double check, triple check to make sure the bases are all the same. Okay, now as our final step, we're going to subtract these exponents. What is 11 take away 12 going to give me? Yeah. Yeah, be really careful with your integer rules. It's going to actually give me a -1. Last class, we learned how to solve a negative exponent. So what do we do? And you can use the shortcut here. If you have a -1 as an exponent, which hasn't come up on the screen yet, but it's coming, how do I get rid of that -1? Abrahami? Exactly. You flip it, so it'll be 6/1 to the power of 1, which is basically just the number 6. And that would be your final answer. Last question. Okay, I really like question 5F, hint, hint. I think it's great when you have fracts anywhere. So again, just like before, I'm going to look at the numerator separately, and then I'm going to look at the denominator. Let's look at the numerator. We have 3 as our basis, so that's great. I know the base is going to be 3 here. And I know the base is going to be 3 here. 6, so that's not not going to change. I'm going to write that down in the denominator. I know. Chalkboard if it takes too long. At the top, add them or subtract them. Sheet of paper on the side, I'm going to add up these exponents. And then this is going to give me 3/6 plus 2/6, which is going to give me 5/6. So basically, I have 3 to the power of 5/6 up here, and then 3 to the power of 5/6 at the bottom. If you have the exact same number at the top as the bottom, what can you do in that situation? Like kind of like, you know how if you have something like 3 divided by 3, what is this equal to? Nashi? It's just equal to a whole number 1. Anytime you have a fraction, a numerator that is the same as a denominator, it's going to be equal to 1. So because these are the same, we know it's going to be a 1. But another way for us to double check it is we can actually subtract these fractions. If we subtract 5/6, take away 5/6, what do we end up getting? What's 5 take away 5? 0/6, which is a 0. So another way to think about this is it's going to give you 3 to the power of 0. What is 3 to the power of 0 equal to? Given? It's just equal to a 1. So however you want to think about it, the answer is a 1. You can either cross them out and equal 1, or you can subtract them, get 3 to the power of 0, and then that's equal to 1 as well. Okay, I'm sorry for this being so painfully with the internet. Your homework, well, you're going to get class time as well after break, but your homework is going to be to finish all the questions on all the sheets in that package. I think some of you are already done. And there are also textbook questions at the bottom. The textbook questions I think are easier than the, what does number 2 say?